Okay, so I was asked to talk about the potential of quantum networking. I've been slotted in the role of more of the user perspective, which fits me and us here at GE pretty well, I think. And well, I guess I'll start out by giving a personal perspective, near-term quantum advantages and gaps that I see. And I may differ in some ways from a lot of the positive attitudes that preceded me. I take a little more skeptical view, and I have to survive here. And that is, for example, I'm in the benchmarking group, looking at quantum computing benchmarking. And, I don't get the sense that we're anywhere near having quantum computing ready yet or being a threat. But I do feel that quantum networking, and Mark and I had some arguments about, or debates, some nice debates about this, whether quantum networking is ahead of quantum computing in a sense. And depending on how you measure that, I think the standards community around quantum networking of necessity is further ahead than computing, because networking inherently involves getting devices to interconnect and talk to each other, and that can only be done through standards. And I do think there's probably nearer term opportunity in networking, like I said, than computing. And depending on how you define sensing, I think, again, we can argue about where we are compared to sensing as well. But I do think quantum networking will be the glue for this quantum ecosystem that's coming up. Without quantum networking, nothing is going to talk to anything else, and it's not going to be as good as it could be. So near-term quantum advantage, like everybody else, cybersecurity is the low-hanging fruit, probably the easiest thing to sell. I would point to the NSA document on the critique of QKD, specifically, and make sure that people are aware of the problems with QKD. And I was hoping to hear how they were specifically addressed in this webinar, but I didn't hear that yet. But cybersecurity, again, seems to be the low-lying fruit, and then sensor networking may be another near longer term than cybersecurity, but still near term benefit. And again, quantum computing, interconnecting, trying to get scalability for quantum computing is probably even further out still. So what are the gaps that I'm seeing? Standards for interoperable quantum computing networking components. Even though I said standards are further ahead, they still have a ways to go. Quantum photonic PIC chips and PDKs, process design kits, need to be developed so that we have tighter integration of things like QKD and other quantum networking components with the actual hardware in which they reside. Because again, if you have bulk optics and trying to connect that to as a QKD system to your equipment, there's a gap between the two. I'd like to have my security physically integrated in my device, and that's only going to happen with, or most likely to happen with these PIC photonic integrated circuit chips. And another, for the longer term sensor networking vision, I think it'd be nice to get people thinking about quantum sensor output, not just quantum sensor detection elements, but output the data in the quantum state that could be processed from the sensors. But for all of this, for computing, which is being very harshly benchmarked right now, we also need network benchmarking, and we need better sensor benchmarking as well. So if you look at I talked about standards being ahead for networking. This is our map that we've been developing in the QED-C of, quantum computing networking and sensing. I know it's an eye chart and probably unintelligible, but I'll try to break it down a little bit. We have the subcomponents on the bottom. So the idea is you could take any standard that's being developed or that will be developed in the near future and throw it on this diagram. And then this diagram should be able to tell us, you know, what areas are being densely attacked through quantum network, through standards development. And then the white spaces in this diagram would tell us where standards are missing or being more sparsely developed. So anyway, sort of common subcomponents for everything on the bottom. We have our computing and sensing, standards development, and of course, applications on the top. And of course, we throw in PQC and these non-classical quantum-inspired stuff. And by the way, this diagram is still under development. It's not the final version, but I just thought I would share it. But I think, again, networking is the glue that's going to connect all this together and make it work. Without the networking part, you just have two standalone pieces. Okay, quantum networking advantage. What would be the advantage? Again, I'm kind of reiterating cybersecurity, but that leads into some religious wars, PQC versus QKD. We look at it, I guess, as some people mentioned, as hedging our bets. You know, we want to have both and see where they best play out. Sensor networking, perhaps, but if you ask me, you know, where in sensor networking is there any possible advantage? Maybe in multi-parameter estimation over a network. And then the holy grail, of course, is scalable quantum networking, as mentioned earlier. I think everybody talks about that one. So a few more gap discussions here. Transduction needs to be addressed. Otherwise, the quantum network has nothing to talk to. The standards and benchmark. But the question is, how do you approach standards and benchmarks? I mean, everybody's very skittish about this. They say, well, we can't create standards and benchmarks until we reach perfection. I take the opposite view. Just create them now. Fail early. They're all going to fail. I mean, they're not going to be. The first standard of anything is generally not good. And so you need to start failing early, and you learn from that and build better and better standards. It's an iterative process. Again, I mentioned PIC chips and process design kits are needed for tighter integration. And it'd be nice to have quantum sensor output that remains in a quantum state. And I don't think quantum sensor folks think in this manner yet. They're all focusing on the quantum sensing element itself. So with that, I think that's all I want to say for now. So